Hello everyone. In this video, let's learn about registers. So first, what is a register? A register is a group of flip-flops with a common clock input. So several D flip-flops may be grouped together with a common clock to form a register. As we learned previously, each flip-flop can store 1 bit of information. So for example, a register designed with 4 flip-flops can store 4 bits of information, and a register is formed with n flip-flops can store n bits of information. So let's design a register that can store 4 bits of information. So here I used 4 D flip-flops, and then as we saw in one of the previous videos, we can have the clock enable input, we can have a clear input as well. So the first thing we need to do is to connect all the clocks to a common clock input. So let's assume this is our clock input. So this is the CLK, stands for clock. So the bubble here, it means those are falling edge D flip-flops, which means they will store data on the falling edge of the clock. So let's connect them to this common clock input. And then also the clock enable, we need to connect it to a common clock enable. So let's do this. So let's connect all the clock enable to a common clock enable. Let's call it this one, the load. Also, let's connect the clear to a common clear input. And we see the bubble here. We learned in one of the previous videos that means it's an active low, which means 0 will enable it and 1 will disable. So let's connect all the clear to a common clear input. And let's call it clear N. Okay, so this way we designed a register that can store 4 bits of information. So let's see how we can store 4 bits of information. Let's assume the initial state of each flip-flop, or they're all clear, and then the state is 0. So this is Q3 is 0, this is supposed to be Q2, Q1, and Q0. And this is D2, D1, and D0. So let's assume Q2 is 0, Q1 is 0, and then Q0 is also 0. So when it's time to load data into this register, so we need to set the load to 1 for 1 clock period. So when we set the load to 1 for 1 clock period, so that means at the falling edge, we will store some data. So let's assume we want to store in this register 1101. So we want to store 1101. So we can give D3 an input of 1, D2 an input of 1, D1 an input of 0, and then D0 an input of 1. And then we have to enable the clock enable by setting the load to 1. So that means on the falling edge of the clock, after the load is enabled, so this data will be loaded into the flip-flops. So this 0 will become 1, and this 0 here in Q2 will become 1. This 0 will remain 0. And then this 0 will become 1. And this data 1101 will stay in this register as long as the load is disabled. So that means if we give any other inputs, let's say we give it an input of 0011, so this will not change what's stored in this register because load is disabled. Remember, we just like enabled for 1 clock period. So if we have a signal like this, and then for 1 clock period from here to here, we enabled the load. So this load became 1, and then after this we disable it. So during this time, we loaded 1101. If at any point later we enter any data to the flip-flops, this will not change what's stored in it because load is disabled. So when we want to clear this data, we can set clear to 0 because 0, this is an active low. So we can clear what's stored in this register by setting clear to 0. And then when we want to load data again, we need to enable the load for 1 clock period and apply the inputs that we want to store in this register. So lastly, let's see the symbol of 4-bit register. So this design here can be drawn as follows. So this is flip-flop, and then we have the clear input, we called it clear N, and then we have the clock enable CE, or the load, and then we have the clock input, this is the clock. And for D to store 4 bits of data, we need to use a bus. A bus is a little bit thicker wire, and then this slash here was number 4. That means this one has a 4 wires. And then also similarly on the Q output, we can use a bus as well. And then this slash mean here, this has 4 wires. So this was the D input and this was the Q output. So this one here is the same as this design here. So to store 4 bits of data in this register, so we can apply 1101 to D and enable the clock for 1 period. So at the falling edge of the clock, we will store 1101 in this register. And anytime we want to clear it, we can set the clear N to 0 because 0 is active. This is an active low. So this was an introduction to registers. I hope this was helpful. Thanks for watching.
Enjoyed this video? Subscribe to the Computer Engineering Notebook for more tutorials on computer architecture, embedded systems, and hardware design. And hit the bell to catch the next one.